Hello and welcome to the OLM Feature Planning and Issue Triage meeting. Today is Thursday, March 18th. On the agenda today, we have several items. The first is from Chris on IBM, which is around how IBM is using OLM and why ODOLM and namespace scope operators exist. Chris, do you want to discuss, take it from here?
Yeah, that'd be great. Can you hear me okay?
Yes, hear you good.
All right, let me turn my video on too. Okay, so we've talked about this in the past, and I wanted to, I guess, a couple things. I kind of wanted just to share what we're up to, right? So we're building lots of applications. Let me share my screen here if I remember how to do this. Share screen. That guy. There we go. So we're I wanted to describe kind of like what we're up to for as far as how we are building large applications and kind of how we're composing them. And then some of the problems we've run into, some of the feedback we've gotten from some customers, and then kind of ask some questions at the end, get us thinking about our futures and maybe how can we improve OLM, or maybe what should we be doing differently, right? So in a nutshell, what we've got is we've got three categories of operators that we're delivering. So we have this thing called a lead or solution operator, which is really kind of like the top level operator that a customer would buy. That could be, we have these things called cloud packs, which are essentially whole groups of lots of different things in the box. But what we've discovered is, the cloud packs are really the granularity because it has a lot of stuff, and we have we only have a few of these big cloud packs, but they're very large and monolithic-y sounding. And so we've developed another operator called a capability operator, and this is really like the core thing that a customer would be interested in. So a customer, they might want the solution, right, because it's a collaboration of lots of products, or they might just want one particular capability within there. For example, like a queue manager, right? They don't want to install the entire product that happens to have a queue manager in it, right? Both of these kinds of operators so all of these operators are in our catalog, in our IBM catalog, but only these two top ones, the lead and the capability operators, are visible, right? So they wouldn't be discovered, they're discoverable and they're installable by an end user. Then we have these component operators, and these component operators are things that are kind of buried inside of it. We still want to use the kube APIs, you still want to use the operator pattern, but they really weren't designed for customers to use directly. So for example, we might have a customized version of MongoDB, or we might have some kind of caching service, things that we want to share within the framework, but we don't want them to be focused. We don't want it to be elevated up to the discoverable area. Then how do we compose those things? So within that, we might have, so using that same pattern, this is a lead operator, capabilities, and components. A lead operator, and all these lines here are hard dependencies, right? So the lead operator may need a little a may need little b, and then so forth, right? All of these things are all composed as a single thing. If they only need A, well, then they only get the things in these sets of boxes. They don't get the big A and the C because they're not needed. But then the point thing here is that some of these components are shared, some of them are not. And OLM actually does a pretty good job doing this as long as everything's in the same operator group and you need everything, right? So if I get A, I get everything that's here, because as we know, OLM only has the required dependency mechanism, right? So it's either all or nothing. So operator lifecycle. So one of the features that we really want is to be able to add what we're calling a soft dependency, right? So what I just said, OLM handles those required dependencies, but not soft dependencies. So how can we install, capability D as an optional dependency? So maybe this component of A could run better, right? Or could improve, could enhance its capability if this operator was here, right? If this other capability was enabled. So this is kind of a soft or an optional dependency. I know Yum, APT, those things have similar kinds of concepts, right? So they run differently if things are available differently. Likewise, maybe there's different storage providers, maybe there's different database providers and things like that that might be pluggable and that kind of stuff. But there's lots of other kinds of things that may be enabled or enabled or disabled depending on how the customer wants to use the thing. So another part is tenancy. So we're getting a lot of feedback from customers where they really want their namespaces to be their tenants. So they've really bought into trying to get their return on investment. They're using Kubernetes the way that it's been advertised. They know about namespaces. They love namespaces, and they really want namespaces to be that tenant. So how do they do that today? Right? So they need multiple instances of operators, which is super important when the operators have been written such that the operand is tied to the operator version. So the operand version is the operator version, right? So that's actually considered a best practice by some groups because it's easier, right? But then you're at the mercy of the operator version. Then there's when you have different instances of operators, you have to make sure that your APIs are 100% backwards and forward compatible because they might be operating at different life cycles, right? So this is where we're going to talk about the descoped operator at some point here. So what do you do now when you have tenant 1 and tenant 2 have slightly different, they've gone askew a little bit on their operator versions. You have to be super careful that you haven't broken the APIs because OLM isn't going to let you, right? They're not going to let you install things in incompatible ways because they have all those protections in there to prevent the graph from getting messed up from CRDs being upgraded in incompatible ways when other operators are using it and so forth. And of course, we need multiple instances of operands. This is far easier to implement when the operator supports what's called the fan-out operand versioning strategy, which we do support in, we're supporting more and more in a lot of our operators. So what that means is we've basically created a schema for our operands and our CRDs for operands that allows the operand to describe exactly what version it wants. So an operator now supports a set of operand versions, and then the actual, the end user, the line of business user in theory, or a tenant admin would have the ability to control what version they want when they want it. So now the operator version becomes independent of the operand version, which is really kind of what customers really expect because the operator is really there to manage the application, manage the component, right? And so we really want those two things to be decoupled in order to get the best tenancy model we can. So OLM also can do this pretty well when you're using the own namespace or operator group or install mode. So that's basically saying each of these tenants is its own operator group. They're completely independent, and everything is installed in that same namespace. So then now we have security domains. So we have these two opposing requirements. So we really want ease of use, right? But we also want security, transparency, and isolation, right? So how do you do that effectively? So in the own namespace mode, you have an operator group and own namespace. The problem with that is you've got the operators and the operands all commingled in the same namespace. They have multiple service accounts. You might be using the operator group service account, but in any case, the namespace really is a security domain, which is a union of all the role bindings that exist. So any of these are operands down here, and these are operators up here. These operands could, in theory, hijack an operator's service account. There's nothing stopping that from happening, right? So it's important for people to understand that namespaces by themselves should not be thought of as a garbage can for all sorts of stuff, right? there's a use cases for multiple namespaces and cross namespace isolation. So let's see here. So this is easy if you do it this way. It's not quite so secure. Customers really don't want cluster role bindings to be used at all, right? So if we do this, we're really limiting on what kinds of operators can be used. And we also really want a restricted SCC, so pod security policy, security context constraint, to be used within these namespaces, or at least use a custom SCC. So OpenShift, for example, comes with a set of security context constraints like run as any user, run as host, there's any UID, there's a bunch of these things out there, run as root. They don't want to run with those because they're a little bit too coarse, right? So they've got, maybe we really want workloads to be able to, and cluster admins really want to know exactly what the security posture is, not just the permissions of the operator, which are in the CSV, which is great, but they also want to know, what the SCC policies are going to be. So how, we've talked about this, numerous times. How can we know exactly if this is going to use any permissions that are beyond what I need? By providing any UID, that's still kind of a large thing, and I'm not comfortable with that. Where's the next one here? Okay, so what about single domain or single namespace? So OLM provides own namespace, which is what the OpenShift UI provides natively when you select one namespace. And then they have this other one called single namespace, which is really dual namespace. So this is the level better, because what this does is it allows you to run the operator in one namespace, and then it reaches in and manages an operand namespace. So ideally, this model would work, but the UI doesn't really support it, and I know there's some hard edges. I think that's the terms that people have been using with me on how do you get this model to work real well. And so this just hasn't been really adopted. So then the other option is custom security domains. So in this particular case, you basically decouple the permissions and the watches. So this is what we're doing in some cases here. So we're using own namespace mode, but we're really not using any operators in it. I mean operands in it. We're just using it for the operators. And then instead, we're just manually configuring the permissions and the watches pieces that the operator groups provide, but not the installations thing. So installation is done on a namespace by namespace basis, but we're actually building a virtual tenant by wiring these namespaces together by essentially creating a pseudo kind of a hybrid own namespace, single namespace mode, right? So this is where I'm going to talk about the namespace Sculpt operator. So what that's doing is it's programming the pieces of operator groups so the operator can reach in and manage the operand namespace, but is not stuck with the single the operator group problem. So this fixes a lot of the problems where operator groups collide, right? So you might have a bunch of namespaces, but you have different operator groups because you have different security domains. So we tried to decouple all that from one another so we could have independent security domains, but yet also be able to have operators operate on the things they need to operate. So we're trying to get as granular as possible, right, to satisfy the customers who really, really want that granularity. And of course, it creates some usability problems. So how do you get that ease of use when you have all of those knobs? So just really briefly to introduce, this namespace Sculpt operator. This was something that a person on our team created as a escape hatch for some customers who really, really wanted this kind of capability. So it operates similarly to that portion of an operator group. You install the namespace Sculpt operator, and it creates you create a CR which basically describes what operand namespaces do you want it to control, to watch, right? And then what it does is it creates a config map, and it mounts it in. You can mount this config map into your pods, and you use the same watch namespaces, environmental variables, and it programs it just like the operator groups did. Because it's a single namespace mode, it doesn't get in the way, right, from what the OLM's been doing. And we've had two variants. The first variant we came out with was like a super elevated privilege version, which basically just automatically looked for all the CRs and all namespaces for all the operators, and it just programmed all the role bindings for you. Of course, some customers don't like that. They really want to run in a restricted environment. And so instead of that, we provide some scripts to help them. So we have a restricted mode, which allows customers to basically program that on the side. So it doesn't have to reach in. It has much less. So it's just basically managing the watch lists and things like that, but it's not managing the permissions for you. So then the other thing which we talked about, I think last October, is the Operand Deployment Lifecycle Manager. So what this does, in a nutshell, these are the things that it provides on top of OLM. It provides Operand instance lifecycle support. So that's the installation of CRs, the updating, the continual updating of those CRs, and the removal of those CRs. So you can create what are called operand requests on the fly, and that'll instantiate those operands on demand. And it also tracks, has use counters, so people can reuse those same instances. You can have basically tenant singletons, right? Things like that. These operands have different configurations. So what they do is they augment the configurations that are stored inside the CSV, the ALM examples. And so you can basically provide different operand definitions that override those capabilities. And so what you can do is you can build a registry, we call it a registry, and configurations for those registries, which gives you a graph of subscriptions that make up your solution. And those are not installed by default, they're installed on demand. So when you request them, then that's when they're manifested. So that's where you kind of get that both worlds. So if you happen to request an operand that requests two operators, those two operators will get installed. If those operators, and they're all installed through OLM, and those operators are installed, if they have hard dependencies and other OLM operators, those will get installed, right? So it goes through that mechanism. So what this does is it gives you a way of describing subscriptions in a very clean way. And so there's no question on what channels you're going to get. You can also choose what namespaces they go in, right? So they don't have to all go in the same namespace. So you can go ahead and provide a declarative way of describing what your solution would be, right? And so you can pick all the EUS channels, if they're all EUS capable. You can pick all the stables or all the betas or whatever makes sense for that. You can build that, and you can build that on the fly. Let's see here. What else do I have in here? Oh yeah, the other big thing here is it handles the what's called operand data binding. So it's really modeled after the app service bindings open source project. So it's very similar to that. So it's basically when your operand is created, the operator for the operand can basically create a secret, that a well-named secret that you're looking for, and then you can use that to be able to connect to that operand service. So key takeaways. So we're providing these services that we've created, and these patterns that we're utilizing are providing soft dependencies so we can resolve these dependencies on demand. So this is important because these solutions, on that first picture, that might have, I don't know, 25, 30, 40 other operators that it may or may not need, right? So manifesting all of those on a cluster when they're paying for PVUs, these different metering aspects for how they pay for these things, it can get expensive, right? And they don't want to see all that overhead. They just want to see what they need, especially when they only need one little teeny piece. They don't want to get all of this stuff in the box. So by providing the subscription registry manifest that allows us to build those optional subscriptions, and it allows us to build these subscriptions by registry parameters rather than just the default things that are inside the catalog or the catalog bundle. And these optional subscriptions, we're triggering those by CR values. So you can imagine this solution might have a CR that basically says, I want to use this feature, this feature, this feature. And then the controller then takes care of enabling the trees, the graphs of all the other operators and operands that needs to be able to manifest itself. The other key takeaway here is our customers have adopted namespaces as tenants. Yes, tenants aren't really there in Kubernetes, but it's what we've got, right? And so they've already gone all in on tenants. So we need a way to decouple the cluster scoped artifacts from the namespace/tenant artifacts. So that's super important for us. We need a way to decouple the security domains. So definitely the operator security domain from the operand security domain. That's a desirable outcome. The first one's more important. The second one is desirable, but not as important. The third one is decoupling the APIs from the controller, right? So the problem is having the controller operating at slightly different levels, the operands at different levels. It gets really complicated. You have to be super careful to make sure that your operator APIs don't evolve past where they break things. So like we might have like somebody running one tenant in EUS mode and somebody's running in continuous delivery mode. And we don't want the continuous delivery mode to overstep and break the EUS mode tenants. So how do you do that? Unfortunately, the only way to do it right now is if you have to introduce a breaking API, you introduce a new API. You either change the group or something like that to completely decouple those from one another. And of course, that really makes it complicated when you're building solutions. And then the other thing, not any less important, but providing that clear user experience for each of those roles, right? So the cluster admin definitely has a role. So he's looking at, what am I installing? How do I set all this up? What is my security domains? How do I enable other people to do their job without me having to do it for them all the time? So how do I enable the tenant or namespace admin, right? And what does that mean, right? And then how does that person do their job within their security domain, right? And then how do they enable their line of business administrators to do what they need to do, which maybe be the developer, it could be a Cognos administrator, something like that. So I think we need to very clearly delineate at least those three personas. Each of those personas, of course, have different looks and feels to it, depending on what the line of business is and so forth. Okay. Punchline. So what, I guess, really what I'm looking for, so I reviewed the descoped operator work, and I reviewed the OLM Gen 2 stuff that you gave us, Evan, last week, just to kind of get an idea what that's looking for. And my takeaway from those two are the descoped operator may or may not help us. So the interesting bits of that are the patterns described at the bottom, right? So will OLM help with those operator patterns? So the child operator per tenant pattern and the sidecar operator pattern. I think the only time this would work for us, we would even be able to use this if those were brought up as first class citizens in that somehow. So let me just pause there and see if you had any questions or comments. Did you want me to go back and re-explain anything? Or I know it was really fast and I put this together just last night, and so it's probably not as cohesive as I would have liked it to have been.
I mean, I thought it was a really good presentation, so I really appreciate it. I think it highlights a lot of the same things we've been thinking about for a long time. So it's nice. It's nice to see you coming to these problems, relatively independently. So that's a lot of validation that like the problems are real. The only question I had, I wanted a little more clarification on, was about the soft dependencies. Yep. I can imagine lots of reasons for soft dependencies, but the examples that you had there kind of seem like they would also just be solved by not specifying a dependency at all. Like your Postgres works better if you install this proxy operator or something like that. So you just don't specify a dependency on the proxy operator. You install the Postgres operator, and then you have a note that says, "Hey, this works." If you install the proxy operator, you get this benefit. And then
yeah, so I guess the question is, how do you do that? So if you don't express let's say we just stopped expressing dependencies at all, or didn't use the CSVs to do that at all, then how do you express those dependencies? You'd have to have some kind of table somewhere and some logic somewhere that knows how to create subscriptions.
Well, that's the part I'm confused about, because if you're automatically creating a subscription, then to me that sounds like a hard dependency. But if the user has to come in after the fact, so I guess maybe if I frame it a different way, let's say we add support for soft dependencies today. Would that just show up as perhaps like a suggestion in the UI of here's some other things you might want to install? Or is there some automated action that takes place? Or
Yeah,
and there'd be like an upfront thing that says, do you want the minimal install or do you want the full install? Which I think is the Yum analogy you drew.
Yeah, there's probably other people on the call from IBM that can probably answer that better than I can. But
Yeah,
go ahead.
So Chris, isn't it actually, it's not only soft dependency, but also conditional dependency? Meaning that if I want to have full-blown option, then I have the full set of operator subscriptions being created. So it's not soft, not only soft, right, but rather conditional, right?
Yeah, I think I probably used the wrong term, right? So I should just call it optional, right? So optional means all sorts of different connotations. Soft, conditional, and I know Yum and APT have all sorts of different words for all those things too, right? And I'm not saying we have to invent all of those words, but conditional is probably a better term of what I was really going for.
Thanks. I think that's helpful. I think we can probably, I think that's relatively separate from a lot of the other issues brought up here. So at least in my mind, that seems like a separate thing.
It is. I think what we've done though is we've built a framework that tends to solve. We're trying to solve these things kind of. It's easier to. I don't know why, but it was easier, I think, to do this with a single operator pattern than it was to create a whole bunch of little fragmenty things all over the place. So this is why, the Operand Lifecycle Manager exists, right? Because if you actually look at it, and I'm not going to go through the whole thing again because we've already done that. And you can play back. I've got links and stuff that you can go ahead and look at it if you want. But it really kind of at least cohesively puts it in. We call it the Operand Lifecycle Development Lifecycle Manager, but it also manages operator lifecycle. You can configure it so it just does this on-demand operator aspect, and you can still create the CRs yourself. But there's a lot of nuances and stuff that have been kind of graduated because it's been around for a while now, probably over a year now, and so we've got at least 2 products inside IBM that are using it actively, and we're starting to promote it and see more and more use cases for this as we come into more composable scenarios.
Yeah, I think the need is definitely there. I think to address some of the questions on this slide, like what is all the stuff we've been talking about in this call? How does that help with these problems? The 2 places that I think have the most overlap. One is for ODLM and the Gen 2 APIs that you're talking about. One of the ideas there is that OLM shouldn't just be able to install things that are operator artifacts, but also things like a configuration, a CR, other types of artifacts. And I think that covers a lot of the ODLM use cases, maybe not all of it, but at least the idea that like I could pick a pre-configured set of operands and maybe that all work really well together, request those for install, and then get all the operators spun up in the back end automatically. I think that part is at least something that we can address with the Gen 2 abstractions. Is that jive with what you're thinking, having reviewed those?
I haven't taken that leap yet. I could see that. Maybe, I was worried that you're going to tell me that, use custom catalogs to describe your subscriptions and build custom catalogs on the fly, because those custom catalogs through declarative index now give you that view, right? Which you could do if you created the like a catalog index image as a kube manifest, right? And you applied that would be our registry in theory, right? So there's probably ways we could twist it a little bit to make that work. I haven't thought hard enough about it yet. I wanted your input to see what you thought. So yeah, that's the key I got out of the OLM Gen 2 wood. You're abstracting out the operator from in fact, I think that's what you're going to talk about, I think you call it ruck pack.
Yeah.
You're going to talk about that?
Yeah, if we have time. But yeah, I think the ODLM solution is kind of building essentially catalogs and dependency resolution for operands. And the OLM sort of Gen 2 stuff linked here is, let's make the artifacts and the dependency resolution and the catalog stuff generic so that you don't have to build new catalog things and new resolvers for new artifact types every time. It's one of those things where it's like, if we had started out this way, then ODLM would have been a plugin for that system. And it's probably like not much. I mean, I haven't reviewed the ODLM source code, but assuming we get to these Gen 2 APIs as planned, it's probably not a huge amount of work to have ODLM just be a plugin for it instead of a separate component.
Is there a question?
A question?
Maybe somebody's just not on mute.
In other words, not really. Oh, but plugins exist for Linux and Windows. In my job, I tend to work on Linux, but we shouldn't lose sight of that. The ecosystem works on Windows. And so people have really we would like to think about opening up the possibility for gRPAC in CNI v2.0. We're running quickly out of time, but Brian, would you like to highlight some cool chain plugins?
Can we mute?
Sounds like that's a different call.
Mute? Yeah.
Okay, I muted.
Yeah, thank you.
Thanks.
All right, so I think so Jiaming and Piotr and I think that's a to-do. So I think the Gen 2 stuff just came out to us last week, and then so we're still kind of consuming that. And so I think that's a good thing for us to weigh in on and see how could this fit in there. So that's cool. So what about the tenancy aspect? So we talked about this many times, and James from my team, who's I think on vacation today, he brought up an RFE, which I've got a link into the agenda, about separating out, one way is to separate out controllers from the APIs, which kind of helps with that to some degree. And now we're getting rid of namespaces, right? Now we're descoping them, so everything's cluster scoped. So that kind of breaks the tenancy model, at least from the operator experience. But then you've got these interesting patterns down there. We're saying, well, okay, well, even though these are operator scope, well, we still have to have a namespace somewhere, right? The namespace has to run some controllers, right? And so how do we manifest those things in the scope of a tenant? So have you kind of iterated on that anymore?
I don't think we've iterated on the patterns themselves. The question here, will OLM help? I think operator framework will help. We're probably going to look towards SDK to provide like libraries to make that really easy to do. But the thing that caught my eye in your presentation was this namespace scope operator. And I don't know how closely you've read some of the strawman sketches, but one of the things that we will need in the descoped future is some automation around RBAC. And so the question right now, so the proposal right now is the way the descoped operator world looks kind of leaves RBAC and automation of RBAC as a thing that we can plug in to. And so I think the namespace scope idea, operator option looks like a really great thing to plug in. I think the question we have to decide over the next few months, I think, is what sort of a default thing we want to ship with OLM with descoped operators for RBAC management. Because I think we do want some sort of automation, and it may well be this namespace scope operator. There's another project upstream that looked like it could be useful called RBAC Manager. It could do some of that, but it's very similar. It's the, if you're just installing an operator and its clusters, it's a singleton, for example, and you want to enable it to watch certain namespaces, and you want to enable users to use the APIs and other namespaces and that sort of thing. You can do all of that just by creating roles and role bindings for everyone in the right way, but you might not want to take all the time to handcraft those, and we can probably come up with some good automation. And it sounds like to me the namespace scoped operator is doing a lot of that type of automation.
Yeah, the important thing with the bad thing about the namespace scope operator, it's another privileged thing that a customer has to install, right? So we're getting by because OLM is part of the platform. And so they kind of ignore the fact that that's running as root. So they're trusting, they have to, right? That's where we're at. And so they don't want any of our stuff, IBM stuff, running as root, right? They want our stuff running in their happy little, their security domain, and they don't want to give us any privileges at all, right? Everything's got to be role-based. So thou shalt not create SECs, thou shalt not create any cluster role bindings, all that kind of stuff. Granted, there are exceptions, like especially when you're installing like CSI drivers and stuff like that, you kind of have to have elevated privileges. Those are special. But for traditional application workloads, you wouldn't do that. So having us have this namespace scope operator is a problem. So we had to kind of chop it off at the needs and create the restricted one, which then all of a sudden made it kind of not super useful, because now you have to have a whole bunch of scripts and stuff to basically manually program it.
And that's the rub, right? Is that if you want to have the full flexibility, like the minimal permission model here is that an administrator goes in and creates all of the bindings that they want manually, right? That's as soon as you want automation around that, then you have a higher privilege component.
I think the important thing is, so I love the Android style permission thing, right? So I think that, and whatever, so an ask, make sure, so we're betting the farm right now because this is what's on the truck, right? On own namespace mode subscriptions and operator groups, right? We have to do it that way because that's the only way we can be composable, right? And plus it gives the customer, it gives us a UI experience because OpenShift, that's what they do. And it gives us the most composability there. And we had to, as we built all this other stuff to wire it all together. So Android support, right? The Android permission support. Don't just add it to the new API, because that's not going to help us, right? Because we can't use that until all the other stuff is built. So what we'd really like to see is the ability to do that kind of thing. So the cluster admin, when they install an operator, they see, oh, this is all the stuff I need. This is my new security domain that I'm building for my tenant, right? And that tenant then also he's operating in a sandbox, and then he can also see, the things that he is being exposed to and within his security domain. So we just want to make sure that the security domains are honored, and we want to make sure that those security domains are visible.
I think one thing that wasn't clear to me is why the patterns you're talking about for own namespace and single namespace mode wouldn't work if you wrote operators for all namespaces. Because in an all namespace operator, it's running in its own namespace, but the expectation is the consumers of the APIs are in some other namespace. Or then the extreme version of that is that you have an operator in one namespace that provides a cluster scoped API. So it actually has no access to any namespaces.
Yeah, the big issue there is customers are running other workloads on their clusters, which may not have operators at all, right? They don't want a CSV being dropped into their namespace, right? They don't want anybody reaching into that namespace. That namespace is theirs, and this all namespace mode is very intrusive for those customers.
Is it the CSV copying? Oh, sorry, Nick, go ahead.
I was going to say, just to be clear, the descope plan isn't make all operators all namespace. It's,
No, I know it's different. I totally understand.
I don't care about. Yeah. So I'm trying to like, I don't know.
No, I'm not saying. So what I'm saying is own namespace. So yeah, all namespace mode is out. You can't use that. Own namespace, a single namespace. Those are really what are interesting to us, and that's what we're gonna use own namespace. For the next year, whatever, right? Because we have to ship something like tomorrow, right? And so that's what we're using. And so we would really like to take advantage of the new security features that are coming, right? Based on that pattern. If we have to completely upend everything and switch everything to a new API, it's going to take a lot of time. And we're not going to be able to take care of we're not going to be able to take advantage of any of those new security features. That's really what I'm saying.
So Chris, like with the namespace scope operator, maybe some of the guys that are on here can speak better, but I think that is basically leveraging the capability of having an array of watched namespaces, right?
Yeah.
So when you say own namespace or separate, it's really that third install mode, which we're leveraging through the namespace scope operator.
Well, we're building a version of that. So as far as OLM is concerned, its own namespace, but we have basically treated it like multi-namespace.
Yeah, I think multi-namespace is actually the trickiest one in our experience to get right. I think conceptually single namespace, own namespace, and then something that's global in the cluster have more stability than some of the multi-namespace ones where you have things colliding, intersecting across namespaces. I had a quick question about the SEC or pod security policies. Is that a really high priority? I see Daniel's not on the call. We were discussing yesterday actually, trying to incorporate where to prioritize this feature, because we want to support all arbitrary objects in bundles, and we also want to potentially support SCCs and other like pod security constraint type objects in the bundle. So we were wondering whether we should put the SCC support ahead of all arbitrary objects or incorporate all arbitrary objects, which I think is slated for the next release, and then we get SCCs for free with that. Does that help? If we delivered it earlier, does that help anyone in a major way?
So I have my own opinion, but I don't know if other IBMers in the call have other opinions on that.
Yeah, so if you can hear me, I'll share an opinion quickly here. So I mean, there's really two camps for bringing your own SCC. If you run with the restricted SCC by default, then it's not really a huge issue because the restricted SCC gets you pretty much everywhere you need to go, with the exception that it does allow privilege escalation in there. So you can make it a little more restricted. But if you need something like NEUID or one of the higher privileged SCCs, then a lot of the times it also grants you extra permissions in that SCC you might not need. So that's where a real use case for custom SCC comes in. So you can provide an SCC with the exact fit for your application or your operator security domain. So there is a higher importance on it when you're not using restricted. But
I was just going to say, sorry. So the important thing is we have got workloads that just can't run with restricted. We've got a lot of workloads that don't run restricted. A lot of things are either legacy or they're doing special stuff, right? And so they need to be able to express at least an extra capability or two, but they don't want the entire capabilities that might come in the box with one of the pre-canned SCCs that are there. That's really the bottom line.
Yeah, and the important thing is that SCCs or PSPs, if you're looking at it that way, are kind of special, because if you create it and put it on the cluster, that's fine, but you still need that RBAC binding to say my service account has this SCC and it can use it for matching by the pod admission controller. So if you just give the ability to, let's say, throw an SCC down on the cluster because it's included in the bundle, then that operator controller still needs either automated access with some higher privileges to create the cluster role and the role binding to bind it into the right service account, or a admin for the cluster would need to do that as a post step. So SCCs and PSPs and these different policy enforcements need to be treated a little specially because they need a binding with RBAC for the actual service accounts to use them.
Yeah, so we're kind of at I'm personally at a crossroads myself. I'm not sure if OLM should be creating SECs. I'm not sure if that's its role either. But I think SEC should be elevated to the customer saying, hey, we use these privileges. Help me create these SECs if I want one. Either I'm going to use one of the canned ones because I'm okay with that because I just want something quick, or I want a custom one because I see that you need this one little extra privilege in here and I don't want to grant you all those other things.
Yeah, I think that based on the customer interactions, we see that none of the enterprise customers are willing to delegate SCC creation to anyone besides their own admins.
Right. So you're thinking that OLM creating SECs would not be permitted.
Yeah, I think if you look at what a cluster admin does for our large customers, their role in life is to make sure that the cluster is stable, and they want to support multiple lines of businesses sharing it. And so they're not going to do anything that could expose them from a stability standpoint, like creating arbitrary SCCs, having permissions that span across different namespaces, because those are different lines of business. They're trying to tightly control who can access what, and are really against any kind of surprises. Oh, these permissions just kind of pop up when I install this operator or its payload.
But OLM is already doing that, right? They're creating webhooks, they're creating CRDs. So is an SEC in a whole different league?
I think the way I see this going with being less restrictive about what goes in a bundle is you'd be allowed to create an SCC, you'd be allowed to drop a role binding in, but then you just write the policy for what is allowed to be installed on a cluster. And it sounds like most of the clusters you're running for customers would have a policy that says you can't install any bundle that creates the SCC.
Yeah, that'd be ideal. Yeah, then they could at least look at it, right? So you could actually elevate it saying, hey, I don't give permission to create this thing, but here, by the way, this is what I think we need.
Yeah, and I think that's where we're skating to.
Okay.
With the new stuff. Yeah.
Right, and if that's related to that, I forget what the JIRA ticket number is, but there was one of them that said, allow the installer of the operator to review the permissions, like the RBAC permissions, as it goes through. If that's related to this, I think that's the higher priority item here, is being able to see, here's everything that I'm requesting. What are you going to allow me to do?
Yeah.
And that one is actually, that's somewhat available today if you're using the manual approval installation. I think we have lots of good ideas to make that better, but if your MVP is you just need to review stuff before it gets installed, I think the manual install should.
Does that address, though, if resources were in the bundle, do they get incorporated into the install plan where you would see those?
They do, yes.
Okay.
The thing that should change with the new APIs is a mechanism by which you could write a policy that rejects the contents of a bundle based on what it contains, or what namespace it's installed in, or what catalog it came from, or something like that.
You guys have mentioned policy a couple times. Is that like OPA policy kinds of things, or something new, or what are you thinking there?
I guess I'll go on record as a fan of OPA, but I think we're not gonna be able to rely on that in the short term, because we can't guarantee it's installed in a cluster, and we're not to the point that we want to vendor it in OLM right now. The policy I was referring to, we're basically planning to copy the CSR approval process in Kubernetes. So you create a a CSR and it by default is not approved, but you can write other controllers in a cluster that do policy on that and flip the status to approved, and then the other controllers that are watching that resource move ahead. So the idea is you pick some stuff to install, some controllers decide whether or not it's approved by default or not, and then you can, it basically makes approval pluggable in the short term, and one of the plugins we could easily write is one for OPA.
Okay, so conditional approval. Okay, got it.
That would actually be a great lead into what I was going to talk about, but with only 8 minutes left, I'm not sure that we want to jump in there.
Yeah, I think probably the proposal, that proposal is super interesting, but it deserves more than a few minutes we have left. I think this was a really interesting presentation, and there's a lot here for everyone to take back and reflect on.
Yeah, I'm not sure what the next steps are. I mean, I definitely have a lot of next steps. I have next steps
Sure.
every day. Maybe looking, I think our team, we're definitely going to start looking at Gen 2 more from that aspect, from how could we merge that or use that to bootstrap or integrate with ODLM, the features that we're looking at there. So that's one thing we can look at. And then I think we need to look more carefully at the policy-driven approval process, which I don't think I've seen an enhancement request for that yet. So I've kind of gleaned some of it from these other Hack.io documents. If you have something, that'd be really great if you could formalize that.
Yeah, so the reason I wanted to present the Ruckpack stuff is because I think it's been marinating long enough that it's time to write an enhancement for it. But we can write it up as an enhancement and then review the enhancement as a group if that's a better order to do things.
I love that way. That's my favorite.
Okay, well, we'll plan that for next time then.
And then another related thing is in the Gen 2 stuff, you guys talk about Depster. So I think there's two Depsters then, right? So if you got the Ben Luddy Depster tool that he wrote, and this is a whole different Depster, right?
It's a whole different Depster. Naming all that stuff was really hard, and I basically just picked names. So if anyone has better ideas for names, those are certainly placeholders. Okay. Yeah, Ben was out when I did that, so.
So there was one thing that came up that I'm not sure. I mean, we were kind of, the IBM team was asked a bit about, you know, should we be looking at SCC support or adding, you know, all kinds of YAML files into the bundle? I don't think we came to terms there to help prioritize that, did we?
So the question is if the work is prioritized to allow arbitrary manifests in a bundle. Is that the question?
Yeah, I think that was kind of, is that the high priority versus trying to do something special for SCCs? I thought that was the question that was being asked. And I'm just wondering what the net of that is. Is it, I mean, are you guys on a mission to allow all arbitrary YAML files in a bundle? Is that something that we can be looking forward to, or?
Yes, I don't want to, I'm not promising anything definitively, but it's been on our roadmap, and we actually looked to implement it once last year, and we are looking to implement that again in the near future. So I was just, SCC is obviously a unique example of an arbitrary kube resource that you can include in a bundle. It sounded like from the discussion that there was still some uncertainty, and potentially our plan of supporting arbitrary objects, which incorporates SCCs, obviously is maybe the more straightforward approach than doing something special and then also offering everything. But
yeah, I think you're gonna have to decide, right? So if you're gonna do arbitrary artifacts, they have to be safe ones, right? So like namespace scope stuff. right? So you're going to have to decide, and then this policy fits in, right? So, okay, for the not safe stuff, what do I do with it? And what is safe?
Well, when we mean arbitrary, we mean arbitrary. So safe is obviously subjective. And the policy, like approval policies or flows, is what protects you from that. Because, you know, as a cluster admin for a specific cluster for a specific customer, you can be in control and decide what you think is safe and what's not. So that's really where we're going with the whole thing. Like, you can't have arbitrary manifests without.
Okay.
Right now, we have a list of things, right? But obviously, what's safe and what's not safe is, from your perspective, is the customers that you're talking to, which is not the same for everybody else that uses OLM. So, like, I don't know if we build something custom specifically for approval of SCCs, if that's what you're trying to get at.
Well, I think what you're saying is that, so arbitrary manifest in a bundle is something you want to work on, and you would include the policy approval stuff as part of that, because you can't do one without the other, right? And then the SCC piece is like, oh, do we bolt that on after the fact, or is it more important that we do a one-off ahead of that? Or
yeah, and what Evan was saying before was that, like, if you have install plans with manual approval, anything you put in the bundle gets put into the install plan when it's resolved, for somebody to come in and approve.
Right, so the problem is you can't manipulate that install plan, right? So it's not like you can just remove the SCC out of it. It's all or nothing.
Yep.
So we would have to be careful if we add, so we would have to have some conditional saying, oh yeah, I want you to approve everything except for that one thing. That one thing is optional.
Yeah, I think that brings up a really good point. When we do support arbitrary objects, we do need that policy or some kind of overview as well to ensure that it's safe without an explicit list of what we like and what we don't like. And so I'd like to just table this conversation because, you know, we can keep talking for another 5 hours, I think, but we have a hard stop at 11, and we can bring over the RUCPAC proposal or just discuss this presentation again in our working group meeting next week. We have another meeting, it's at 3 p.m. Eastern next Thursday. So I'd like to call it. Thank you everyone for coming. The recording will be on YouTube as well. If you want to look through the presentation again, it'll be on our YouTube channel. And hope to see everyone in our working group meeting next week. Thanks,
Thank you.
everyone.
Great, thanks guys, appreciate it.